Thanks to LastPass for sponsoring this episode. LastPass relieves the burden of remembering passwords. Click the link in the description or stay to the end of the video to learn more. If you've ever had a conversation with Siri or Alexa or your Google Home, it might seem like machines are just a couple of steps away from being fully conscious beings, things that actually experience the world. But since we only have insight into our own experiences, humans are the only things we know are conscious. And the fact that we are is one of the most obvious things about us. It's part of what makes us human. Even so, figuring out exactly what consciousness is and whether or not it could emerge in non-human things has stumped us for centuries. Scientists can't even agree on whether or not it's possible to study something that's so personal using the scientific method. But some say that it's not just possible, it's necessary. A theory of consciousness could help us figure out if a given coma patient is likely to recover. It could influence the way we treat animals, and it could even help us navigate our relationship with technology. So since the 1980s, researchers have been taking a crack at figuring out consciousness from a scientific perspective. For now, we are still nowhere near solving it, but we have learned some things about what a theory of consciousness might eventually look like. Except, first things first, we have a problem with figuring out consciousness. It's that we have to define what it is. It's hard to put a finger on exactly what it means. For most purposes, you can think of consciousness as the name for what it feels like to experience the world, rather than just interact with it through inputs and outputs. And yes, every interaction starts with an input. The things we see and smell and hear in our environment turn into electric signals that travel through our brain thanks to charged atoms moving in and out of neurons. But somehow, the movement of those atoms can create the experience of hearing music or smelling a rose. And that experience? That is consciousness. If you don't see how that's different from a robot responding to an input with an output, think about this. Your body responds to lots of stimuli without your conscious involvement. For example, food makes your mouth water and cold makes your hair stand up, but you don't have to be conscious of those things for them to happen. They just happen. Like a robot. On the other hand, you're conscious of the way things smell or feel. You're aware of what it feels like to be you. And while your subconscious brain has countless processes happening in parallel, your conscious experience is a single stream of events, almost like a story. So you can think of consciousness as meaning experience or awareness. And scientists more or less agree up to that point. The question is where to go from there. The study of consciousness as a scientific thing, as opposed to a philosophical one, took off in the 1980s with Francis Crick, a neuroscientist and, yeah, you've probably heard this name, co-discoverer of the double helix structure of DNA. After he'd basically decoded life, he was ready to take on what he saw as the next big scientific mystery, consciousness, and he recruited a bunch of young researchers to get involved. But Crick and his collaborators didn't set out looking for the ultimate explanation of consciousness. Instead, as a starting point, their goal was to find the part of the brain that gave rise to it. I mean, it wasn't universally accepted that consciousness began and ended with the brain, and it still isn't today, but that was most people's starting assumption. This team called what they were looking for the neural correlates of consciousness. And over the past few decades, they and other scientists have made some progress. For instance, some research suggests that conscious experience is rooted in a part of the brain called the posterior cortex. But again, this is still a correlate of consciousness, not a cause. So even if they do manage to narrow down the thing that gives rise to consciousness, scientists still face the biggest question: how? In an attempt to get to the bottom of that, two major ideas have emerged about how we might study consciousness in a scientific way. That is, with testable hypotheses and measurable results. Neither one is an actual answer at this point, but their goal is just to find ways to study this subjective experience using rigorous science. So they may be off base, but at the very least, they offer ways to approach the problem that are scientifically testable. The older of those ideas is called the global workspace theory. It was developed by the neuroscientist Bernard Bars, and it's been around in some form since 1982. It suggests that there is a network of cells in your brain called a workspace that's at the root of your conscious experiences. At any given time, you got all kinds of signals milling about in your brain, but according to this theory, this workspace is kind of like the fan cam of your brain. Any signal that happens to be processed by those cells gets broadcast to the rest of your brain, and you become conscious of it. This workspace is really limited, though, and it can only hold so much information at once, which could explain why information and ideas drift in and out of your consciousness so easily. Like you might be fixated on an annoying sound and then forget all about it as soon as someone involves you in an interesting conversation. What we don't have is any proof that this idea is correct, but there is some preliminary evidence for it. For instance, in an experiment published in 2001, a team of researchers had 15 participants look at words flashed on screens for 29 milliseconds each. That is long enough for a word to become readable, but in some cases the experimenters used a technique called masking to prevent the subjects from consciously registering the word. They did that by flashing another image after the word, which interrupted their conscious processing. By imaging the participants' brains, the researchers were able to see that the words that remained subconscious only produced a small amount of activity in the brain, while the words that the participants became conscious of triggered a whole flurry of activity in many different regions. This wasn't necessarily proof of the global workspace theory, but it did give the experimenters a clear picture of the brain areas involved in subconscious and conscious processing of the same signal. And in later research, scientists have used that as a starting point to try and figure out how messages that pass through this network might get broadcast to the rest of the brain. It is still far from a solution to consciousness, but this theory does a few things well. For one, by suggesting that conscious processing is limited to a specific network, it offers a possible explanation for why our conscious brain is only capable of narrow streams of thought, even though our brains can subconsciously process so many things in parallel. But more importantly, the fact that it involved questions that were testable gives us a way to study consciousness using the scientific method. The theory still has its sticking points, though. Like, it goes one step further than the neural correlates of consciousness, but it still doesn't provide the ultimate how. And then there's also some resistance to the idea that consciousness is computational, that it just comes about because of the way the brain is hooked up. Because if that's true, it suggests that in theory, there's nothing keeping machines from gaining consciousness, that it's all a question of having the right wiring, and that would open up a whole different can of ethical worms. But it is a testable hypothesis, and in science, that counts for a lot. This isn't the only hypothesis out there, though, and others take a totally different approach. For example, in 2004, the neuroscientist Giulio Tononi proposed what he called integrated information theory, or IIT. Since it's impossible to scientifically observe someone's personal conscious experience, even if we can see some of what it looks like in the brain, Tononi crafted his theory by working backwards from the few things that seem to be universally true about consciousness. For one, we know that it's subjective, meaning that you are the only person having your conscious experience. No one else can step in and experience what the world is like for you. Second, we know that the experience of consciousness is unified, meaning it can't be split into pieces. Like, you are one thing, you cannot willfully split your sense of self into two selves. You also can't, say, decide to only process certain kinds of information. You can't wake up tomorrow and decide you're only going to see the color blue or only smell nice things, although I think that would be a handy skill. Tononi took these observations as starting points, along with the assumption that consciousness somehow comes from our web of interconnected neurons. Then he proposed that consciousness comes from the amount of interconnectedness in a system, or in his words, the amount of integrated information. IIT suggests that essentially the whole of all your neurons working together amounts to more than the sum of its parts. So connected neurons can create an experience that individual ones cannot. Again, not everyone is on board with this idea, and testing is still in an early stage. But researchers have done some preliminary experiments that compare the amount of connectivity in a brain to a person's level of consciousness. For example, in one study, Tononi and his collaborators rounded up 11 volunteers and used a magnetic pulse to deliver a burst of stimulation to neurons in their brains. Then they used sensors on the the scalp to measure the amount of activity that pulse produced. Next, they sedated the subjects and performed the same experiment. The second time around, the pulse produced much less activity, suggesting that there were fewer connections between neurons, so that triggering one group of them didn't set off the same chain reaction that it had the first time around. It's still not possible to directly measure the amount of connectivity in the human brain, but experiments like this can serve as a decent proxy, a way of figuring out if there really is a link between integration and consciousness. If there is, that implies that consciousness exists on a spectrum. And when you play this theory out, it implies that not only could machines become conscious, but everything with any amount of interconnected information, from a wasp to the internet, might already be a little bit conscious. Like the global workspace theory, IIT doesn't yet provide any kind of satisfying answer to the problem of consciousness, and the consequences also seriously challenge things we instinctively believe to be true about the world. So if it's true, we might have to think a little harder about how we interact with things. Still, the idea of measuring interconnectedness provides a path for exploring consciousness scientifically. And like with the global workspace theory, that is what makes this idea stand out. These hypotheses are still works in progress, but if either one proves true, it could help us figure out what has consciousness and what does not. Like if IIT is right, measuring the amount of interconnectedness in a brain could help doctors and scientists decide how conscious a coma patient is. Or it could help future computer scientists answer those same questions about artificial intelligence programs. On the other hand, if the global workspace theory ends up being right, and if scientists can identify that workspace, the fan cam of the brain, doctors could look for activity in that region to see if a patient has any signs of consciousness. So far, neither one of those ideas is developed enough to be useful in any practical sense. So for now, there's no foolproof way to identify consciousness. And until we understand how it arises, we probably won't be able to say what has it or not either. But the fact that we are conscious means we're going to keep being curious, and scientists are going to keep looking, as long as the problem is unsolved. Thank you to LastPass for sponsoring this video. LastPass saves you from having to remember your dozens or hundreds of passwords. If you're consistently getting locked out of your accounts or resetting passwords, LastPass can help. With this app, you never have to write, remember, or reset your passwords. You can store an unlimited number of them or share them with a trusted team member. LastPass autofills your credentials in your browsers, making it fast and easy to log in. You can also find the app on iOS and Android and sync your passwords across devices. To start using LastPass today, check out the link in the description.